This is part 1 of 2. In this video, I'm showing you how you can connect a text LCD screen to our 328 microprocessor. I'm going to show you the hardware first, the hardware connections, and then in part 2, we'll look at the software that we have to write in C. So as far as the hardware is concerned, we'll need to connect ground to ground, and the ground of the 328 goes to the ground of the LCD screen. And then the screen that I have is a 5-volt screen, so it needs to be connected to 5 volts. Next, because I'm always writing to the screen and never reading the screen, data always is going from the left to the right here, from the 328 to the LCD screen. I can make the read-write line a low voltage. Low voltage on the read-write line means that you're always writing to this screen. If you are reading the screen, you could make the read-write line a high, but I'm not doing that. So I connect ground to this, and it can always stay ground. Next, I'm going to send some data to the text screen. This data will be done in parallel, and I'm using 8 bits. So I'll need 8 wires to go from all of port D to the data input of the text screen. Now again, this will be 8 wires. It's a lot of wiring. And for that reason, serial screens have an advantage because they use just one wire. It's less wiring, and also it's less wires on the board, which makes for smaller boards. And that's an important cost consideration. Serial data can be done more cheaply, but parallel data can be done more quickly. Next, the text screen needs to know if you're sending a data or an instruction. So I'm going to use port C, bit number 4, to designate whether the data is actually a letter or if the data is an instruction. A letter would mean I want the screen to display a letter like A through Z. Those are letters. An instruction would be something like clear the screen, or go to the home position, or skip to the next location on the screen. Those are commands, instructions to the LCD screen. And those instructions would be sent on port D. So port D contains not just the instructions, but also the letters. So the problem is, how does the text screen know when it's getting a letter or an instruction? Well, this port C, bit number 4, if it's a high, that means the screen is getting a letter or data. And if port C, bit number 4, is a low, then the LCD screen is getting an instruction, like go to the home position or clear the screen. So again, that bit determines whether the screen receives a letter or a command to do something. Well, in your software, you're going to have to set up port C to the right value, set up port D to the right value, and then prior to anything happening, the enable line has to be made a high. So this PC5, which goes to the enable, port C bit 5 going to the enable, you must bring it to 5 volts, which is what this waveform is showing you. So initially port C bit 5 was a low. I set it to a 1, and then I then drop this line to 0 or a low. Before this enable goes low, you must make sure all the lines above it, like the port D and the port C, are finalized. You must finalize all these lines, values, before the port C bit 5 goes to a low. So the order of events is you can make the enable high, you can put the value on port D, you can put the value on port C, then you can drop the enable to a low, and at which time the LCD does the job, whether to display a letter or to do the instruction. Also, one needs to wait a little bit of time for the LCD to work, and I'm choosing to use a millisecond. So after I drop the enable to a low, right here, I then call a delay subroutine for a millisecond so that the LCD has time to do the job before you give it the next job to do. So on the next letter to display, you would again repeat the process of raising the enable, setting up port D, setting up port C, and then dropping the enable. I don't wait much time before dropping the enable. If it doesn't work when you're trying this, you may want to have a small delay before you drop the enable. I do use a delay after I drop the enable.